Circuit protection is evolving over time, and it's incredibly important now to understand whether our devices are uni or bi-directional. Let's go back and think about a standard consumer unit. We're so used to the electricity going out from the consumer unit and feeding things such as our socket and our cooker. However, with microgeneration in the form of solar and micro wind, all of a sudden now some of our circuits actually send electricity back into our consumer unit and feed the other circuits within the installation, or possibly export that electricity. Those devices being fed in from that inverter need to be bi-directional. Now, the on-site guide has tried to help us identify unidirectional devices. So if I look here in protection, we can see on the second page within there, we've got some drawings to suggest what would be a unidirectional device. However, I think they've drawn them upside down. The single screw here would be the one for the bus bar, and the outgoing part of the two here. So if we look at a RCBO, we can see two screws at the top and just the one screw at the bottom, not like these drawings here. So I think they fool us slightly with their layout. Let's look at the devices themselves and see if we can work out whether they're uni or bi-directional. So this is an RCBO. We're used to seeing this within consumer units. And we've got at the top here, we've got neutral out and line out. And at the bottom, we've got line in. Now, it could be you're looking at a device slightly different from this. It could be using arrows or other words, but because it's using words to suggest what is in and out, this makes this one a unidirectional device. So the circuit going out here goes off to feed our cooker, our sockets, etc. This connection here is for our bus bar. Let's look at the next device and see what we can see here. Now we've all of a sudden got a very similar RCBO. And this RCBO has got exactly the same layout. It might slightly different in positions of switches, etc. But now it says L1, N1, L2. Now you could be thinking this is in and this is out because that's the standard layout, but it hasn't defined the device as the supply coming in or the supply going out. Therefore, this is a bi-directional device. They also sometimes write on the device itself that is bi-directional, but you can tell because it isn't labelled for its connections, the electricity can flow in both directions. So we would be happy to have this connected to a inverter where the electricity would come into here, but also go out of here because it is bi-directional. And this is a great improvement in our electrical industries because we thought the first massive improvement we did was the following: by having consumer units full of RCBOs, meaning that we have individual circuits on a type A RCD, and therefore if we had a fault it only disconnected one circuit, and that was great. And for the majority of these circuits it's probably still fine, but when you start introducing microgeneration, you've got to make sure the device that is feeding both out and in that circuit must be bi-directional. All of these, as we can see from the writing on the top, they say L out and neutral out. Therefore, these are unidirectional devices, and for the majority of our circuits would be great. And at the bottom here, we can see the L in on the bus bar itself. So these are unidirectional devices, and if we added one, we'd have to add one like we see before. However, in between this, we had this style of consumer unit, possibly the split load board, where we had both an RCCB and an MCB. Now, we've got to work out back in the day whether these were bi or unidirectional. Well, let's start first of all by looking at a standard MCB using the knowledge we've just acquired. So this MCB here has no markings on the top and no markings on the bottom. Therefore, just have a quick think, this is actually bi-directional. So our standard MCB is bi-directional. If you fiddled it round, you probably could wedge it in upside down. Obviously there's a DIN rail connector here, but it could go either way round. But that is actually a bi-directional device. So in older installations where, say, solar was installed the first time the boom came around, it could have been in one of these type of boards. This device by default was actually bi-directional, but then we've got the RCCB to look at. So let's look at that next and bring that back in. So our RCCB here is now got to work out whether this is bi or unidirectional. It says 1 and N on the top, it says 2 and N on the bottom, and then we've got our MCB. Because it isn't defined in and out, we know that this makes this device actually bi-directional. So back in the day with these old split load boards that we've said now, they need to be removed. There's only one RCD protecting many circuits. If that installation had, say, on the end here, a MCB going off to feed a solar inverter, the MCB and this RCCB are both bidirectional, and that installation obviously is correct. We haven't got to worry about those devices. So strictly speaking, it's only the next iteration after this, when we went to full RCBO boards, that we have the problem and we have to identify them. So possibly with some help from BS7671, which I don't think is as much help as it can be, we could look at this older consumer unit. When you say older, it's just been improved slightly from the point of view that we can see that these are unidirectional. This RCBO on the end needs replacing. It would need replacing if you had an inverter for, say, micro wind or solar PV, with one with no labels on defining its direction, making that then bidirectional, removing the unidirectional device that's already there. This is something you want to keep an eye out on, things like EICRs as well when you're going in there, just to confirm whether the device is correct for the actual circuit it is. And we saw in those older ones where default, it actually does mean it complies.